In this video, we're going to talk about pointers in C++ and why do we need to know pointers in C++. So knowing pointers is essential. They provide powerful tools like how to manage memory, how to interact with data, how to build efficient programs. So here are some of the main reasons that we can think of, and there might be a lot of other reasons, but I'm just naming a few so that we know, at least like when we are reading, we can think of all these reasons. And I will give you like one simple analogy with every one of them. So let's say for the first one, so it says like we will have efficient memory access. We'll have access to memory will be very easy. In a way, we'll have direct access to memory and we can manage memory locations. The example of this one would be like, let's say if you have a map, so the map takes us to exactly direct location, we can pinpoint. Okay, so the second thing that we can think of is like data structure. So knowing pointers will help us to build advanced data structures, i.e. linked list, trees, graphs. And knowing pointers, it's as if like we know the roadmap for city planning. And so let's say like different elements are linked to each other. And again, for each and every one, we will have very detailed examples in C++ and different analogies so that we can remember it for longer. Okay, so maybe the third one, resource management. So we can manage memory files, devices explicitly. Example of this one would be like, let's say we are borrowing a book from library, right? So we know like, okay, where exactly the book is located and how do we get it and how do we return back into the library. Like one of the other reasons would be like flexibility. So it enables low-level programming. It works directly with hardware and memory buffers. Let's say the example of this one would be like we have universal remote control, so we can change whatever we are controlling. This is like, again, for each and everyone we'll have examples, or like by the time like we get to like examples, you will you will be able to think like this, and you will know like you can apply all these analogies to the real life examples. So let's get to another reason. So we can dynamically allocate memory. So it allocates memory at runtime, which is not in C++. Normally in C++ you have to do everything like in advance, but with pointers you can allocate memory dynamically by using the new keyword and delete. Like new, we are creating like memory location, allocate memory, and delete, we are releasing the memory. So let's say like one of the examples that I can think of would be is we are renting a toolbox and we use it, we work with it. By the time we are done with those tools, that we return it back, right? So another reason would be function argument. So it passes large structures like i.e. objects and structures and objects by reference. So giving instead of like, let's say one of the example would be like, let's say if I'm giving someone the address of my home, so I only have to give the address of my home, then the key to my home, right? So this is how like we can use it like as a function argument. Another reason that you can think of is that it provides like multiple indirections. So it creates pointers to pointers for complex data structure. As if like, let's say if another example that I can think of for analogy, like let's say we are writing a note, we have a paper. So I write a note in it and I pass it to another person, and he writes something and he passes it to another person. It goes on all the way to it gets to the very last person. So these are like very technical things that we need to know about pointers. So let's just think of some of analogies or like real life examples. Okay, so let's say like what is like in a scenario like, let's say if you have pointers, right? And in pointer I will think of a library, right? So let's say in a library I have a book, right? If I want to give this book to someone, let's say I want to give this book to like 20 people, right? We have 20 people. So each and everyone, they can come, they can access directly the book that that we have in the library. They can read it, they can return it back. Every time they're done, they'll return back to me. So, and if I bring any changes to this book, like let's say to this book, if I bring like, let's say if I change like numbers or any other checks in it, right? So everyone like from there on, like whoever comes, they will see the book with the changes made to it. Unlike in the scenario of like, I mean, if you don't have pointers, so let's say we have 20 people, right? So everyone who comes, I mean, they'll have a new book with them. So that in a way that like we have to create copies of the book for all those 20 people, right? And at the same time, they like if I bring any changes, right? Like let's say I brought some change in this book, right? Then I have to manually bring in change to this book, to that book, to all those books, right? So it's like very much inefficient. But unlike in pointers, so we could easily save time, we saved space or memory. Like let's say we didn't have to keep 20 books, we only have one book, and that's more than enough for us. And last but not least, if we bring any changes, like the updated one would be available, I mean, all across the program, right? So this is an example. Again, I mean, with pointers, we can, like, these are like very simple analogy, or simple way that we can think of it is that like we can save time, we can save space, and everyone will have the updated version of, I mean, that thing that we are working on it right now. Okay, another analogy, like if I think of in memory, like how it works. Again, this is like very simplified way of thinking about a stack. Okay, about memory, about pointers. So okay, so normally stack will be here and heap will be here. Okay, but for the sake of simplicity, I will bring it down here. Okay, so let's say I want to have stack here and heap memory here. Okay, so pointers, using pointers, I mean, and this is our main part of the memory. Okay, so meaning that my main whatever we are declaring, like let's say inside int main, right, it only have access to stack memory, to the stack part of the memory. So what do we do? Like let's say if I needed something to access, like in heap, right, or like any other resources, right, then we cannot access that through main. What do we do then? So we have to create a pointers here, so that pointer could point, I mean, to heap, to other resources, anywhere, any place, right? And again, this is again very, very simple way, or like simple analogy of pointers. Okay, let me go through one example. So let's say I created one variable, so the type is integer, the variable name is x, and I assigned 10 to it. So let's say right away it was created where? In stack memory. In stack memory we have x, inside it has 10, and the memory address or the memory location is called, it's located at AA1. Again, this is an hexadecimal number, it's a big number, so like it's assigned by the computer. I'm just giving you an analogy so that you know this is a memory location where it physically exists there, right? So don't think of this like, I don't know, like a real memory location. Okay, so it's just a memory location. Now I'm creating a pointer. Again, pointer could point something in stack memory, in heap memory, or anywhere else. Okay, so I'm trying to create, for the very first example, I'm trying, I mean, to create a pointer. So this is how we create pointer. Int, like the data type of the pointer is integer, and when we say star, and then that means that we are creating a pointer, and pointer, like I just named it PTR, and I'm assigning this location, memory location of x to it. So now this pointer is pointing to the memory location of x, which is AA1, right? So now you see, like, I mean, this is how it works. And again, we will work on how, like, the examples of pointers, like how do we print them out, how do we update them, and all those, like how do we see out them, like all the changes, right? So this is a very simple analogy, like how it works in memory. And then we will think of, like, we will work on a lot of examples so that it's crystal clear, so how exactly it works.